Today we're going to look at finding the area of a circle. Now remember, with area, what we're looking for is how many squares of a certain size would fit inside of a space. So it's a little bit hard to think of putting squares inside of a circle, but we kind of need to remember and keep in mind that that's what we're doing. How many square units will fit? Now, the first thing we need to know is, what is the rule or formula for how we find the area of a circle? And to show you that rule, I'm going to just kind of do a little bit of a demonstration here. Think about splitting a circle in half, just like this. I've got half of it's blue, half of it's yellow. And then I'm going to take it and further split it into each of those sections into pieces. And I did that because in just a minute I'm going to rearrange the pieces. Remember, when I rearrange the pieces, I am not changing the area. I'm simply making the space, making the pieces just look different. I'm putting them in a different shape, but it's still the same amount of space. So here's the space that I want to turn them into, or the shape I want to turn them into. Now, when you look at that, something should pop into your head that we've already studied, namely a parallelogram. And we know how to find the area of a parallelogram. Believe it or not, the formula for area of a circle is related to the formula for area of a parallelogram. So let's think about the parallelogram that we can see here. You can kind of see this parallelogram. Now, my lines aren't perfect, but you get the general idea. And so now we need to think about what we know about the area of a parallelogram. The area of a parallelogram is area equals base times height. Now, on this circle that we've rearranged to make look like a parallelogram, we need to think about what the base and the height are. So when we look at this, the base of this parallelogram is here. That's our base. Now think about that base for just a minute. That base has all of the yellow edges of the circle in it. When we think back to all of the edges of the yellow circle, the yellow part of the circle, do you see that that's halfway around the circle? So what that really means is the base of the parallelogram we have formed is half of the distance around a circle. Well, we know that the distance the whole way around a circle is called the circumference. So the base of our parallelogram we have made is half of the circumference. So 1/2 times the circumference. Well, we know that circumference is pi times diameter. So 1/2 of pi times diameter. Now, thinking about that a little bit more, we should know that half of the diameter is the radius. So we really can rewrite half times pi times diameter as pi times radius. So the base of our parallelogram that we can make from this circle is pi times the radius. So we're replacing base with pi times the radius. Now we need to look at the height. The height of the parallelogram, if you look at that carefully, notice where it goes. It goes from one of the pointy tips of one of the pieces of the circle all the way to the other side. So look at our original picture here, or look at what we did. Notice that if we go from the tip of one of those pie pieces all the way to the edge, what have we drawn? We have drawn the radius. So what that means is the height of our parallelogram is really equal to the radius of the circle. So we can replace the word height, or the height there, with radius. So there is our formula for area of a circle. Pi times radius times radius. You'll usually see that written as pi r squared. That's how you'll usually see that formula written. So now let's look at applying that formula. Looking at our first example here, 3 2/10 is our radius. We need to use our formula, area equals pi times radius squared. Now, I would like to point out to you, I often say to keep from making mistakes with the exponent, because who wants to make our lives more complicated? I always just put pi times radius times radius. Then you don't have to worry about just accidentally multiplying the radius times 2, which happens a lot, actually. That's a common mistake. So we're going to do here 3 and 1400ths times our radius is 3 and 2/10 times our radius of 3 and 2/10. If I work this out, I'm going to get an area of approximately 32 and 1500ths square meters. Let's look at another one. We again know that the formula for area of a circle is pi times radius squared, or pi times radius times radius. So in this particular case, we're going to use 3 and 1400ths for pi. Our radius is going to be, don't get fooled by that 8 yards up there. Remember that 8 yards is the diameter. We want just the radius. So if the diameter is 8 yards, then the radius must be 4 yards. So we're going to do 3 and 1400ths times 4 times 4. And that's going to give us an answer for our area of approximately 50 and 2400ths square yards. Looking at one last example. Again, area equals pi times radius times radius. So we're going to do 3 and 1400ths. This one again was a diameter, so we need to find the radius. Half of 17 is going to be 8 and a half, or 8 and 5/10 feet. When we work this one out, 3 and 1400ths times 8 and 5/10 times 8 and 5/10 is going to give us a circle with an area of approximately 226 and 8700ths square feet. So really the key here is just to make sure that you are using the radius, not the diameter, and make sure that you're actually doing radius times radius, not radius times 2, because often people will confuse radius squared with radius times 2. That would be incorrect.